So good day, ladies and gentlemen. So today we just want to look at how do we solve problems that involve indices and how do we apply the rules of indices. For example, if you're given basic indices problems. So for example, you can see the expression here. How do we simplify it if we're given such? So you can see here in this section for number one, you've got x squared multiplied by x3. Now this can just equate x squared multiplied by x cubed. Okay, I can still use the dot, it signifies multiplication. Okay, so if now you've got such a case, the bases are the same and it's multiplication, you just add the powers. Okay, that's how you simplify it, you add the powers on top. So here basically you're going to have something like that, bases, and then it's going to be 2 plus 3. Okay, yes, and then eventually, which means your answer is going to be x to the power 5. Let me just create a bit of space here. Okay, create a bit of space so that we can see what we're talking about. Okay, so here now you've got 2 plus 3. Okay, so eventually your answer is going to be x to the power 5. Okay, that's how you simplify it. Okay, that's how you simplify it, because they're the same basis as x, and it's multiplication. So if that's the case, you just add the powers of both x's so that you can get simplification of x to the power 5. So now let's move on to the next one. Now in this case, you can see that we've got a division statement. So now this is actually division. So how do we apply indices if we're given something like this? So now first of all, we do the same thing. We've got x to the power 4, y to the power 3 divided by x to the power 2, y to the power 2. So now if it's division, you subtract the powers if the bases are the same. So you can see now here you've got x4. So this is equals to, so x4, so I can write it. Okay, x4 is divided by x2. We'll multiply, we've got y3 is divided by, just separate so that you can see y to the power 2. So once you have such a situation, then things become much easier when you're solving. Okay, we just didn't create enough space. Let me just do what I did for the previous question so that I have more space. Okay, so now here, what do we do now? Since we've got this is easily translated to x4. Since it's division, you subtract the powers if the bases are the same. So x4 minus 2. So multiply by y3 minus 2, because you're dividing by y2. So now eventually when you simplify, what you're going to get is x to the power 2 multiplied by y. Okay, so it's to the power 1. So this stays 3 minus 2 is y to the power 1. Okay, so it's x squared y. So final expression is just going to be x. And if you place the 1 here, so eventually it's x squared multiplied by y. So you've actually simplified that expression. That's much easier when you look at it in that aspect. Let's look at one that is a bit rigorous, a bit tricky. How do we solve this one? Let's see, how do we solve number 3? Just create space. Okay, so now if you're given a situation like this, you just do the same thing. It's very similar to number 2. So now basically what you're going to do, this is equals to, so it's 2x minus 2 and then you've got y here. Then this is all divided by y3, y minus 3 times x to the power 4. So we've got something like that. So it's division, so you take like terms and apply the rules. So the same basis for y, okay? You see how you subtract the powers? Same thing applies to x. How do you subtract the powers? So you can just leave 2, okay? And then what you're going to have here, you're going to have all multiplied by, so if x minus 2, so it's going to be minus 4 to the powers, all multiplied by y, which is y, 1 minus 3. 1 minus minus 3, what are we going to get? It's plus 3. Okay, that's how it's going to be. And then what you have there when you solve this, because these are directed numbers, it's going to be 2x. Here is going to be minus 6 to the power minus 6, all multiplied by y to the power positive 4. Okay, and then eventually what you do, this is the same as 2 multiplied by y power 4 all over x to the power positive 6. So you just take it below the division line, or when you make it a denominator, the negative sign will disappear. Okay, so this negative sign will disappear when you make this a denominator. Okay, so you just converting to writing its inverse. So those are the rules of indices. So that's how you simplify that expression. And if we look at this one now, the last one, it's straight to the point. Since you got numbers here, you're just going to, so it's 2, the same basis. So you have 2 to the power 2. Let me just remove this. It's 2 to the power 2 plus 1, okay, plus 0, okay. And then what you have is 2 to the power 3, okay. You can even solve it in a different way. You can solve it in a different way. Since this is just 2, you can have 2 to the power 2 plus 1. And then this one, let's multiply by 2 to the power 0. 2 to the power 0 is the same as 1. Okay, so eventually you're going to have 2 to the power 3 multiplied by 1. Okay, it still gives you the same answer, which is 2 to the power 3. Okay, you can expand this if you're required to calculate, but here we're just required to simplify, not necessarily to solve. So that's how you apply the basic rules of indices here. So if you're given a negative expression, like in this case, whenever you've got x minus 1 is the same as equals to 1 over x to the power 1, so that one becomes positive. So that's how you write it if it's a negative power. That's the way you can express it. So we use that rule. Okay, here we use the basic rule. If it's division, you are going to subtract the powers if the components have the same basis. Okay, same thing applies here. You add the powers for the first one if it's multiplication. So thank you very much for watching. See you in the next lesson.